So I'm going to talk about black swans, those rare and unpredictable events that has a huge impact, and we're kind of blind to them. I'm going to talk about the philosophical aspects of them, so bear with me at the beginning. I'm going to talk about how it relates to us as software engineers and what we do. About a little bit about the experience we had in LivePerson about breaking the monolith and its relationships to black swan events. A little bit about system fragility and antifragility and how to live happily in a black swan infested world. So a bit about myself. I'm a software architect. I've been writing, designing, architecting, leading development software in the last 25 years, actually a little bit more. Mainly in web-related worlds, but not explicitly. For the last 3 years, I've been doing it in LivePerson, building their new LivePerson product, the new flag product, which is a huge distributed system. I'm going to dive into that a little bit down the presentation. So black swans. This is the definition. It's an event that comes as a surprise. It has a major effect, and we're kind of blind to it because of the fact that we rationalize it to ourselves in hindsight. And it was coined by a guy called Nassim Nicholas Taleb in 2007. And the black swan is a metaphor. Before the discovery of Australia, everybody knew that swans were white, and everybody in the old world. And it was around the 16th century that Australia was discovered, and with it, black swans. Now, while it's not such a significant event, and you might ask yourself, why do you call such an event a black swan? It does show us one significant restriction. We had thousands of years of being sure that swans are white, and millions upon millions of confirmatory sightings that swans are white. It only took one negative sighting. A single black, rather ugly bird. So there's a limit to the way we can see the future or predict from the past. So if you look at black swans in the world, you can actually see that most of the major things that happened in the history of the world are black swans. Inventions, telephone, electricity, the internet, medicine, invention of penicillin, for instance, wars, financial crisis, invention of the wheel, everything is a black swan. We didn't see it coming. It had a huge impact, and we kind of explained to ourselves why it happened. So the philosopher Bertrand Russell has, I've told you it's going to be a little bit philosophical at the beginning, but I'm going to get to software. Has a more toxic version of the black swan metaphor. Think about a chicken in a chicken coop. Every day the farmer comes in and tends him, gives him food, gives him water, and every day for 1,000 days the confidence of the chicken that the farmer is a good man grows. At the day 1001, literally the sword drops and it is taken to the butcher. Now, again, what's interesting about this is the fact that the chicken is actually at the peak of his confidence. He has 1,000 days of confirmatory sightings that the farmer is a good guy. But the future is not linear, okay? So Bertrand Russell calls it the problem of induction. It's actually a really interesting philosophical question about how can we logically go from specific instances to reach general conclusions. And it looks like we're wired to think linearly. It's like it's intuitive for us that if yesterday was a specific way and the day before that and the day before that, the future would look like it. So Taleb splits the world into two kind of environments where unpredictable stuff happens. So take 1,000 people and measure their height. You would get a distribution between 1.4 and 2. 3 and an average of 1.7. Now take the tallest person on the planet, which I don't know exactly what the height, let's say 2 meters and 50. Add him to the tally. What would be the average? You might get an increase of 0.5%. Now take those 1,000 people and measure their wealth. And now add the richest person on the planet to this 1,000 people. Let's say Bill Gates. What would happen to the average? Okay, all those 1,000 people collectively would become a rounding error of Bill Gates' earnings on a single day. The average would jump thousands of times. So what it comes to show us that there's two kinds of environments. One of them might be distributed like with what we know about the bell curve, the normal distribution, when things are collected in the middle, and when you get to the edges, it gets very, very, very low percentages of happening. And the other part is more chaotic, the other environment. Taleb called the first one Mediocristan, where things are more predictive, more routine, more obvious. And the other one is called Extremistan, where things are more chaotic. Now, if you take a look at the here on the left, you can see this is data taken from one of the LivePerson services. It's an API call as measured from the client side. It's hard to see, but you can see that on the left side, I zoomed in, and you can see that it's about half a second average access time, not one of our best APIs. And it's like jumping up and down, and there's a jump to 5 seconds, but there's a jump on the right for 5 minutes. And one single instance that took 5 minutes. We have no idea why. Maybe it was a GC, I don't know. But the environment actually is more relating to Extremistan than to Mediocristan, because it's 100 times more in time. So in Mediocristan, you can see that things are distributed differently. I collected a list of things that belong to Extremistan and things that belong to Mediocristan. On the left, Mediocristan, height, weight, calorie consumption, artisan income is like carpenters and bakers. They have to work for everything they do. Okay, they cannot sell the same bread 1,000 times. On the right, you can see Extremistan environments like wealth and income and politics and inventions and websites. You can see the distinction between those two is that on the left, the Mediocristan environments are more physical, are more bounded. And even dice games that belong on Mediocristan is actually very, very bound. You can think about when you're throwing a dice, you have only 6 options. And this is why the casino always wins, because they can plan it ahead. It's a Mediocristan, it's a normal distribution environment. They can know that the edge points of you throwing a dice 40 times in a row with getting 6 doesn't happen, not at least in 1 million lifetimes. On the right, you have informational stuff, and informational stuff which is highly connected and unbound. So this gets us into software, where information goes. We're handling information on a daily day, on a daily work. This is our main focus. And I can safely say that software is in Extremistan. And we're actually generators of Black Swan. There's a short list that there's many, many more things like it in the world that you can see that software made a huge impact on our lives. For instance, if you take a look on video rentals, in 2004, Blockbuster had 60,000 employees in 9,000 stores. Today, 11 years later, Blockbuster doesn't exist. And it's all because of streaming media and downloads, okay? We're living in Extremistan. We're manipulating information for a living. We're actually an industry that drives Black Swans. So one of the things that you cannot do in Extremistan environment is predict. And if you take a look at those quotes for industry leaders, you can see funny quotes like there's no reason for anybody to have a computer at their home at 1977. That's a few years before the PC appeared In 1995, the 3Com founder said that the internet would explode and collapse. And of course, it's funny to laugh at those, but the magnitude of the errors is not what important here. What's important is the fact that we keep on predicting. We think we can predict. So we kind of started to understand it in the software industry, that we cannot really predict. And there was a time that I was signing my emails with this slogan from Douglas Adams about deadlines and the whooshing sound they make as they fly by. We understood that waterfall approaches are bad for us. They're not giving us the benefits. Actually, studies show, and I canvassed some studies for this presentation, many studies show that IT projects and software projects in general fail, like they're late in time, they're over budget, and sometimes could bring a company down. So we were late. We're starting to understand that it's bad to use the waterfall approach, and we're starting to use agile approaches, which, again, in an environment that you cannot predict in, this is the right way to go. Go quickly, make a quick circle, get a feedback, and fix your assumptions and generate the next iteration. But we have another one of those black swans in our more daily, day-to-day work. It's called a bug. It comes as a surprise. It has a major impact if you're not lucky. And we rationalize it in hindsight. So usually we feel like idiots after writing such a bug, and it takes us about 30 minutes to write another one. Right? So imagine yourself the worst programmer you can think of. A good friend of mine gave me the perfect definition of that kind of a worst programmer. It's a diligent idiot. It's a guy that really wants to do good, would go into the code, couple everything together, write bad code, connect everything, and it would look like it's working at the beginning. But then strange things start to happen. This guy would be a generator of black swans. So do not produce black swans is one of the slogans you need to think about when you're adding your next line of code. So in 1986, a guy called Fred Brooks, a Turing Award winner, wrote a very important paper called No Silver Bullets. And in this paper, he claims that he can't see any significant single improvement in us handling the complexity of writing software in the next 10 years. Okay, he was predicting for the next 10 years. I can safely say almost 30 years later, that he's right. Although we got better, we have more models, we have refactoring, we have DSLs, we have software as a service platforms. Still, it looks like the essential complexity, the problems that we need to solve, and the accidental complexity, the complexity of the platforms we run on or the tools we use, are way too complicated for us to predict in. And it's really obvious if you think about the environment being an extremist environment. We just cannot predict. There's no mathematical certainty in predicting. It just cannot be done. So there's a principle of subsidiary, that things should be handled by the smallest possible unit that could manage it with efficacy. Now, you might think that comes from software. It actually comes from the Roman Church. But it actually correct. If we take things, make them as small as possible, that means that we generate the smallest essential complexity. And then we're building a thing that has the least amount of interconnectedness and as simple as it gets. Or as Einstein says it, make things as simple as possible, but not simpler. So I'd like to talk a little bit about what we had to do in LivePerson when we decided to break the monolith. We had a huge code base, million lines of code. One of the classes in that code base was 90,000 lines of code, I kid you not. And LivePerson is a big company. We handle about 40 terabytes of data monthly we save to Hadoop. We have about 2 billion visits handled over 100 different services today after the new system is running in place. We've done it over the last 3 years. And about 1 million events per second in peak times. So we use all those techniques to make our system simpler, make the system more robust, using active-active approaches and cloud. We're actually using a private cloud, an OpenStack-based solution, thousands of nodes in production. And it's all about making it simpler, making it more robust. And we realized that this monolith approach, this monolith program, was so big that we couldn't move in it anymore. Any change would make us go through very, very rigorous testing, and it took months to get to production with a new version. So, but more than that, we had to work on our QA cycle, on our DevOps stuff, and in the QA it's interesting. Remember the Black Swan, that it took one negative evidence to debunk millions of confirmatory sightings? QA is about that. Take your code and try to break it. Try to break it as fast as possible. Try to break it as good as, because of single negative, sighting of your code breaking is much, much more important than your code is running for 1 million times. Taleb calls it via negativa. So it's all about resiliency, robustness, simplicity. But is that enough? Can we do better? Can we do something which is better than that with our code? So in 2012, Taleb coined another term, antifragile. So what do we mean by antifragile? We know that our systems could be fragile, right? This monolith I just mentioned could be fragile. So take a box of delicate wine glasses you want to send to your friend in, say, Kamchatka. And what would you write on that box? You would write fragile with big letters, and you would hope that they would handle the package with care. Now, what would be in that box if you want to write anti-fragile on it so that they would handle it with this care, like do not care about it or throw it around, and it would gain from it. So in other words, anti-fragile, usually when I ask people what is anti-fragile, what's the opposite of fragile, the answer would be robust, resilient, solid, but that's not true. The opposite of fragile is something that gains from disorder. Because a fragile thing, it loses from disorder, right? If it gets a hit or a shock, it would break. A solid system doesn't care. It would stay the same. You can throw it around, it would stay the same. But an anti-fragile system would gain from this randomness, from this disorder. Now, think about the world that I just described that we're living in, this extremistan world. We're actually living in a world that is random, that is unpredicted. We need to write systems that that can take advantage of it. Actually, if you look at the software world in a bigger scope, all those companies like Microsoft and Google and Facebook, they were all black swans. They all used the randomness of the environment, something that was unseen and unpredicted and could take advantage of it. So there are systems in the world that are anti-fragile. Take it, for example, our immune system, our bodies. Evolution, nature itself uses evolution, which is an anti-fragile process. It would gain from shockers by getting us a little bit different in our biology, and then allow us to for the survival of the fittest. Some people would die, but the benefit of the kind would be better. The species. The brain, for instance, we're thinking, we're learning from our experiences, well, for the most part. So something that has more upside than downside from shocks, from stressor, is anti-fragile. So we're an unpredictable environment. We need to embrace uncertainty. So instead of writing a robust system, I'm not saying not to write a robust system. It's important to write the system robust. But there's a little bit more, to write it flexible. And a flexible system would be able to react. So flexibility is about embracing uncertainty and making the wrong mistakes. Yogi Berra was once asked, at the baseball, legendary baseball coach, was once asked, why did he lose the game? He said, we made the wrong mistakes. So behind it hides the fact that we have to make mistakes in order to learn. Not making mistakes is not good, because eventually we would make a huge mistake. Again, extremistan, and it would hit us hard. We need to make small mistakes, make them at the places where it doesn't hurt us much, learn, and then react and build the system better. So if your system is running for 1,000 days, how can you know that it's going to run for another 1,000 days? Think about it. So if you're in mediocristan, the historical evidence is pretty good because the chances of edge cases are very, very exponentially small. But if you're in an extremist environment, and you are, how can you build a system that you can be sure that's going to be up and running another 1,000 days? So it's about getting us the options, putting the options in our hands. For instance, an example for that would be the cloud. The cloud gives you the option to grow if you succeed, if you write your system correctly so it can grow. But you don't have to pay the money for that. That's an option. So optionality is an anti-fragile feature. Reacting, quick reaction, quick turnaround to things is also anti-fragile. Let it crash approaches and stuff like that. So uncertainty should not be our enemy. It should be our friend. So it's like a circle, if you will, of antifragility. We're part of an ecosystem of building, trying to break, deploying, getting a feedback, and doing it all over again, making our system more and more reactive, adaptive, flexible, in order for us to solve the correct problem, in order for us to be anti-fragile. So I made a list, it's kind of hard to see, of things that belong to the fragile part of the area of the world, to robustness and into anti-fragile. You go from fragile to anti-fragile through robustness. So for example, you can say that the waterfall approach is fragile and the agile approach is anti-fragile because you can react quickly and learn. Same for from physical machines to cloud, for Elastic Cloud specifically, again, the example I just gave. You can learn you can grow very, very quickly, but you don't have to pay the price for holding thousands of servers in production before that. Microservices would be also an example for that because it allows us a quicker turnaround from the business point of view, because we can write faster code without changing everything. And again, the experience we had with the monolith is that every time we wanted to change something, it was so painful because we had to check everything around it. Now writing a microservice is like self-contained. I just write it and deploy it and it's working. An interesting example is the rules versus machine learning and AI. If you have a rule-based system, which our monolith system was based on, you set the rules, and then the world change. And you need to go and change the rules, right? And change again. And if you're not doing it quickly enough, and sometimes it's not humanly possible even to do it quickly enough, if you move to the machine learning part of the anti-fragile area, you can now allow the system to learn, create predictive models. It's kind of, predictive, but it's learning in a cycle. If you do it quickly enough, you will not get into the, let's call it the hooks of being stale or being with static rules in your hand. So bottom line is, we need to move from extremistan to mediocristan as much as we can. Make it simple. We need to expose ourselves to positive black swans. We need to play around with technologies. We need to try things with our customers in small doses, in places where it doesn't hurt us, but the gains could be significant. And generally thinking Antifragile is getting us the options, getting us the upside and not the downside. So, takeaways. We're in Extremistan. If you have to predict, just remember that you're in Extremistan and be skeptical about it. Because if you make an error, if you can make a big error, it could cost a lot. Use the negative approach. Try to find the boundaries of your system. Try to prove that things do not work, or find the bad things in systems, the areas. And it's important because, again, the black swan metaphor itself, it's the one single negative sighting. Think anti-fragile. Give yourself the options to succeed. And make things simpler. And if you just remember that things in Mediocristan are bound and disconnected. So events are disconnected, and in Extremistan, things are highly connected and unbound. So if you move your system to areas when you know that, I don't know, an API call is not connected to the next API call, and you have boundaries on the time it takes or the resources it could make, you are moving your system into Mediocristan. Not completely, but it's better. And most importantly, don't be the chicken. Thank you. Question?
So just out of curiosity, based on what facts did you put relational databases as Antifragile? Is it like data-wise, scaling-wise, or so it's really out of curiosity?
I knew that people would ask. That's the excellent question. You know the difference between an excellent question and a good question? Good question is, an excellent question is a good one, which I know the answer to. So, I think,
what was the question?
the question was about putting databases, relational database in the fragile column. And for the mere fact that relational databases are, you can store the data in a single place. You cannot actually, and the idea behind the ACID idea, okay, it makes everything connected together, and you have no way to really distribute it or make it with this approach in hand, and it's actually more fragile. It doesn't mean that it's bad. In some cases, you need to do that, and you can do it anti-fragile when you like slice it or shard it in very specific ways, but the concept itself is more fragile. When you move to NoSQL systems like Cassandra, when you can just add nodes, and it's actually, if nodes comes down and comes back up, it will automatically fix itself, is actually, again, more robust. And we might start getting into the anti-fragile world with databases, but this is a place where I'm not completely, have anything.
From a scaling point of view.
Yeah,
Okay.
yeah. Anything else? Thank you.